honeybee health and activity. So pretty sure most of you are aware of this, but I want to make sure that we address the fact that we have a very successful and large blueberry industry in this state. We're the third largest national producer, and in 2014 we had close to 95 million pounds harvested from 9,100 acres. And this represents about 16% of national production. We also are leaders in organic production at the national level, and the industry is still growing. However, despite this success, we do have challenges. And one of those challenges is pollination. Or we suspect it is pollination because we tend to have very low fruit set in Washington. And that's particularly the case in Western Washington. Now, pollination or pollination services are really important for horticultural crops. Over 130 different types of crops are pollinated by honeybees, in particular Apis mellifera. These are bees that are traditionally brought to growers in hives by a beekeeper, and they're allowed to pollinate a crop. As I already alluded to, there are reports of poor pollination. Prior to me coming here and talking to growers about what are their problems and what can I do as a small horticulturist to help address them is help us figure out how we can improve pollination and fruit set in blueberry. Now, in Western Washington, Dr. Strick has done some nice surveys and tell us sometimes we can get 50 to 60% of fruit set in Western Washington blueberry, whereas elsewhere, even in Oregon, they can see 90% or more. Now, blueberry is capable of setting 100% of its flowers, and 80% is considered a full crop. So if we're at 50 to 60% here in Western Washington, we're not reaching our full yield potential due to low fruit set. And really looking into the literature on honeybee pollination here in Western Washington, there's really very little if pollination is actually limited, what is limiting it if it is limited, and how we can start optimizing pollination. And improving pollination and fruit set has become a programmatic goal of mine in the small fruit research horticulture program. So pollination might be limited by several factors, and one is weather. Here in Western Washington, we tend to have cool, wet springs, and honeybees really are active during low temperatures, wet, rainy, windy conditions, which can often be encountered during the bloom time for blueberry. There's also the issue of floral morphology, and there's a really lovely paper, I believe it was published in 2013 by Chrysalis et al., that looked at floral morphology in different varieties of blueberry, and this is from British Columbia. They looked at Draper, Duke, Blue Crop, and Liberty, and the image on the bottom underneath that flower demonstrates that. And they found certain varieties based on the morphology, such as the opening of the flower or the corolla and the distance between the anthers where the pollen is produced and the opening can be related to preference among honeybee. There's also this interesting issue of pollinator and crop coevolution. So blueberries have not co-evolved with honeybees. They're a North American native, and the European honeybee is from Europe. So it's not necessarily the best pollinator for this crop. Other species like bombus or bumblebee or the osmia species are more adapted for pollinating blueberry. Landscape features as well as management practices as well may have an influence on honeybee activity. And then there's the issue of poor hive health. And this relates to colony collapse disorder in a way. And that seems to be, we don't have any single cause for colony collapse disorder, but that's where we're seeing decline in the number of bees in our hives, where bees are just flying out and not returning. And it seems to be a combination of several factors. Most of all, varroa mites and potentially some of the miticides that are being used. But then there's other possibilities like the genetics, the nutrition of the bees, so on and so forth. So this brings us to the pollination study that I'll be presenting on today. And I had the pleasure to work with Ramesh Sagili at Oregon State University and Elizabeth L. at Simon Fraser University had input on this project. And the objective of this particular project is to survey and evaluate honeybee activity and its role and yield within Washington highbush blueberry. And we're trying to look at what are some of the potential limitations for honeybee activity and how it might influence fruit set and yield. Long term, the overall goal of this research and other types of research is to help develop guidelines and management practices that can help growers and beekeepers work together to promote pollination, fruit set, and yield for the specific conditions encountered in Western Washington and the Pacific Northwest. So I mentioned this study was done over the course of 2 years, 2014 and 2015. In 2014, we worked with 16 grower cooperators, 10 in Western Washington, Skagit County and Whatcom County, and 6 in Eastern Washington, and those being in Benton County. And 4 of those sites in Eastern Washington were organic sites. In 2015, we had more growers participating. We worked with 18 growers, 12 in Western Washington. So we added 2 organic grower sites in Western Washington, 6 in Eastern Washington, and 6 of those sites were organic. So we had the 4 organic sites from Eastern Washington in 2015 and 2 in Western Washington. And we collected data from established Duke plants that were in this area of 15 to full bloom, 100% bloom. We measured pollinator activity using the method described by Chrysalis et al. With some modifications. We collected between 10 o'clock in the morning and 4 p.m. in the afternoon when temperatures were greater than 55 degrees. And we looked at 30 bushes per site, 10 bushes per row, and we counted only legitimate visits. These were actual visits where a bee went in and visibly pollinated the plant, no nectar feeding or just landing on the flower. We also looked at honeybee colony strength, and Ramesh was helpful in coming up with the method without us physically having to open up the hives and looking at the brood. And what we did was we measured the number of incoming bees per colony within 1 minute and repeated that 5 times per day for each day that we visited and collected these measurements. And we collected measurements at a minimum of 3 days per site per year. Some of the other data that we collected, we looked at berry number per bush, mean berry weight, and yield estimates. We also extracted seeds and looked at seed number and seed quality. The rationale for that being if there's more pollination and subsequent fertilization and development of seeds, then we'd be able to enumerate that and measure that. We also looked at various weather variables, and then we provided grower summaries and reports per every year, just so that the growers know where their activity is at relative to others, and ask them to provide a few other pieces of information to help verify colony stocking rates and the yields that they received on that property that we were looking at these for the study. And then we looked at comparisons across locations within between Washington and Eastern Washington and Western Washington. And we looked at the relationship between some of these measured variables like yield and visitation visitation on measured variables like yield and so on. So now I'm going to go over and present some of these data. So this first graph shows average number of honeybee visitations per minute in Eastern and Western Washington. So on the y-axis, we have average number of visits per minute, and on the x-axis, we have the various sites. The blue bars are data from 2014, and the red bars are data from 2015. So you can see sites 1 through 6 are from Eastern Washington, and 7 through 18 are from Western Washington, and then 3 through 6 and 7 through 18 are organic sites. And there were differences across sites, and I'll discuss a little bit more, but one of the strongest differences that emerge is that we had higher visitation rates in Eastern Washington relative to Western Washington. And that those behavior is likely due to weather conditions being more conducive for their activity. However, most sites were below the 4 to 8 honeybee per bush recommendation that Rufus Isaacs at Michigan State University and his colleagues have recommended for blueberry. And it's particularly the case here in Western Washington. On this next graph, we are looking at honeybee strength in Eastern and Western Washington, and that's on the y-axis. And then we have our sites. These are the same sites that you from the previous slide. And there were differences across sites, and there were differences between years. There was more honeybees coming into the hive in 2014 than there were in 2015. But regardless of that factor, all sites were still below the 100 bees coming per minute recommendation. Now we'll look at a little bit of the environmental data, and we collected these data from close by WSU Ag WeatherNet stations, and we looked at temperature, we looked at precipitation, and then we looked at solar radiation. And so this slide we have temperature, and we have 2014 furthest on your left and 2015 on your right in this slide. And we have divided it by Lynden because most of the sites in Whatcom were in the Lynden area. And we looked at Mount Vernon weather data because the sites in Skagit County were in Mount Vernon, and then Prosser because the sites in Eastern Washington were around Prosser. And what we can see here is that temperature conditions in Eastern Washington were greater for the bloom time. And these are just data between the bloom time, so April and May, between the periods that we collected data, 10 a.m. and 4 p.m., and these are averages. So similarly, here's solar radiation and radiation on the y-axis, and we again have the years 2014 and 2015. April is in blue, May is in orange, and then the average is in green. And again, these are data for, sorry, a little closer. Okay, it's flopping down. Does it just detach or? Okay, I'll just hold it. All right, I think we're working. Okay, and these are still data from the period of bloom, April through May, 10 a.m. to 4 p.m. And again, what we see, there's actually, higher levels of solar radiation in Eastern Washington, which we would expect given the climatic conditions there. And then lastly, precipitation. This is similar to the previous slide, blue and orange are April and May respectively, green being the average precipitation on the y-axis. And what's interesting is that there's a strong year effect, which you're all probably aware of, that 2015 was a very dry year. So see, these are some of the additional results. So when we looked at estimated yield across the various sites, we did see differences, but we really didn't see any differences in yield based on region or management practices. And really, from my observations, the yield was really affected by the size of the plants. Other variables showed some regional and management effects, and this is demonstrated in this table here. So we have region, Eastern and Western Washington, and then we have average honeybee visitations, which I want you to look at first. And there was no year effect, so these data are just compiled together, or averaged together. So in Eastern Washington, we have greater number of visitations than what we see in Western Washington. And then when we look at the average number of honeybees entering a hive per minute, this is our estimate of hive strength. We did see a year effect. There was, the figure showed, there was greater strength that we could estimate in 2014 versus 2015. And there was a regional effect. It was greater in Eastern Washington relative than Western Washington. Berry size was different in 2014, but it was not in 2015. An average seed number per berry, there was no year effect, but it was different between the 2 years, and it was for both berry size and average number of seeds per berry was greater in Eastern Washington than Western Washington. And then so some of our regression analyses, so this is where we looked at some of our predicted variables like honeybee visitation or hive strength, and our fruit variables like seed number, yield, and etc. And we really didn't find very many significant relationships. We did see that seed number was slightly related and positively to honeybee visitation rate. So more seeds if the visitation rate was greater, which is a relationship that intuitively makes sense. And berry size was also positively related to colony strength. Again, this intuitively makes sense. If we are fertilizing more seeds, plant seeds release hormones that stimulate larger berry size. And berry size demonstrated a weak, but still, again, positive relationship with seed number, as I just discussed. So now I'm going to shift over and start talking about some general recommendations about pollination, promoting pollination and yield in highbush blueberry. And the first is honeybee management. So the first thing that growers can do is to try to source their honeybees from reputable sources and to use strong hives. And strong hives have a minimum of 45,000 bees per hive. Right now, the stocking densities for bees and blueberry ranges anywhere from 1 to 2.5 hives per acre, but from my observations, we're typically seeing greater than that here in Western Washington, and our poor climatic conditions can justify that. So we're still trying to figure out what is the optimum number of hives per acre. That's going to be a bit of a process, but it depends on weather conditions, and there's some variety differences too. Some varieties are more favorable to bees than other varieties. You want to make sure that those hives are placed around 5% bloom and no later than 25% bloom. And it's nice to help elevate those hives and have them facing an eastern exposure. That helps the hives warm up quicker so that they're hopefully out earlier, as opposed to if they're down on the ground, they might warm up later. And the bees are pretty sensitive. Honeybees are sensitive to temperature. You know, if the warmer it is, the more that they're active in our springs. And then we want to make sure that we're keeping the entrance open. This is a picture that I took, and it doesn't really show it very well, but the opening was obstructed by a lot of weeds, and that can impede honeybees from entering and exiting their colony. So we want to make sure that the bees can easily enter and exit their hives. And then it's recommended to remove the hives after petal drop. So cross-pollination is another way that you can improve berry size in blueberry. So many cultivars of highbush blueberry benefit from cross-pollination, and you can see increases in fruit set and berry weight. So you can see increases up to 58% in fruit set and up to 33% in berry weight. A lot of this is variety dependent though. Some varieties like Duke, for instance, can set pretty large berries with very little seed set. But it can still benefit from from cross-pollination. But there are some varieties that do benefit from cross-pollination and more than others, and those include Aurora, Blue Crop, Duke to a limited extent, Draper, Brigetta, and Blue Jay. And so what's recommended, and this is a recommendation coming from Jim Hancock in Michigan State University, is to promote cross-pollination by alternating rows of different varieties that have overlapping bloom time. So they made the recommendation of having 4 to 10 rows of one variety and then 4 to 10 rows of another variety, which is nice. It's a nice recommendation, but I can understand where it might be a little bit difficult to implement that in the field situation. The other thing that can be done is to encourage natives. And, you know, one question might be is, well, why natives? Well, a lot of our natives, like bumblebee species, have co-evolved with honeybees. So they're very effective at pollinating these specific types of flowers and their corresponding flower morphology. And there's bumblebees, and then there's other smaller bee species like Osmia, which are the mason bees. One thing that these species are able to do that honeybees are not is sonication, or that's buzz pollinating. So they're able to vibrate, and what that vibration does, it causes the anthers to release more pollen than what a honeybee's anthers to release more pollen. And then as a consequence of that, the bee itself gets more pollen on itself, and it's able to carry that to another flower and pollinate it. And honeybees are not able to do this. In addition, these species are active at lower temperatures and are active during longer periods of the day. So some things that you can do to encourage native pollinators is, one is conserving natural areas and habitats around the perimeter of your planting. You can do increasing floral reserves through wildflower strips that will attract more wild pollinators, and it can also provide diverse food sources for them. There's also a benefit that can have to honeybees that are brought onto your land. No or reduced tillage can also be beneficial because there are ground-dwelling bee species, and tillage can disrupt their colonies. And then there's also this recommendation of, you know, reducing your pesticide applications if you can, particularly insecticides. And I'll talk a little bit more about pesticides a little bit later on. If you're really interested in promoting natives, you can purchase bee boxes. But again, use care if you're introducing natives, because not all quote unquote native species, or not all bumblebees are native to our area. So we want to exercise care in selecting quote unquote native species, because we don't want to introduce them and to disrupt the ecology, and they can also carry disease with them and harm our natural populations. So floral diversity can be very beneficial, or has been shown in some various studies that I reference here on this slide. Hedgerows and flower strips, they increase floral resources, and they can help increase pollinator richness and abundance. And that's been a demonstrated economic benefit to this. And what these flower strips do is they provide diverse food sources for natives as well as honeybees that are brought onto your land, and they can stimulate them. So, you know, there's this misconception that they might detract honeybees from pollinating your crop, but really once a single honeybee makes a relationship with a species, it will continually visit that particular flower species. But the collective hive won't just visit one type of flower type. They will go to multiple different flowers. So the pollen in the actual hive is a very diverse from various species. But if we have more diverse food sources, a more vigorous hive, that can be a benefit to stimulating the bees to pollinate more. So I want to touch on pesticides because that's a delicate topic. Pesticides are needed for crop protection. That's just the fact of the matter here in Western Washington. And they're applied during our bloom times, and there's both organic and there's conventional options. There's concern that chronic and both acute exposure can impact pollinators negatively. And really, we just need to be careful when we're selecting and deciding the timing of application, particularly insecticides, because honeybees and other pollinators are insects and they can be impacted by insecticide applications. So some words of recommendation are to follow pesticide levels, and then the EPA has a new bee advisory. So a particular product might be more problematic for honeybees or other pollinators. They will have specific recommendations on how to apply that product. There's also a really great publication by Hooven et al. From 2013 that discusses various strategies that you can do to reduce the potential for bee poisonings from pesticides. A lot of it does rely on grower and beekeeper cooperation. So if you're a grower, talk with your beekeeper, talk about what products they are or are not okay with, and just try to work on a cooperative agreement on how you can be applying pesticides and be protecting their bees. It's also recommended if you have the ability to try to apply later in the evening so that product has more time to dry, if that's feasible. And then if you're having to apply insecticides, particularly during the bloom time, try to pick insecticides that have the least toxic and shortest residuals to protect pollinators. When you're making applications too, it's good to avoid applying pesticides on the hive, so maintain a good buffer. Try not to apply the product on water sources that bees might drink from, and also wildflowers that bees might feed from. And then right now there's also recommendations discussed in this publication to avoid mixing insecticides with fungicides, as well as surfactants in some situations. Just try to apply the straight product. And the rationale for this is that there's emerging research that the synergistic effect of some of these pesticides with fungicides can be harmful to bees than if they were alone in isolation. But that is a very emerging field of research. I often get the question about honeybee attractants as a way to promote honeybee visitation in their fields here in Western Washington. I did a really small preliminary study with this product called Fruit Boost in 2014. It's a queen mandibular pheromone. It's meant to be applied foliarly on the plants and stimulate honeybees. And what I saw is that there was some slight increase in honeybee visitation at the high application rate of this product. But when it came to looking at our various measures of fruit set and berry size and seed number, we didn't see that difference manifest in the plant or in the berries. So, the data at this point is really not suggestive that it has a big impact on increasing honeybee activity. And the variety that we used in that study was Blue Jay, which is known to have difficulties with pollination. Brood pheromones, on the other hand, and Ramesh Sagili has worked pretty extensively with this, have shown promise. And the brood pheromone is pictured on the lower part of the slide. These are meant to insert in the hive, and they're a honeybee brood pheromone. So brood is the larvae in the hive, and they stimulate the bees to forage. The more brood, conceivably, the more stimulated the bees will be to go out and forage. So this mimics that brood pheromone, and it's supposed to stimulate bees to forage more. And we've seen some positive impacts of that with in carrot, and Ramesh has been looking at that in blueberry. So some conclusions as I wrap up. Honeybee activity, what we saw through these data in these first 2 years of the study, are below recommendations, particularly here in Western Washington. And, it looks like the regional effects, temperature might be most to blame with that, but we really need to look at this further in terms of trying to dissect what are the reasons why we're having reduced honeybee activity and verify what types of impacts it's having on our crop. So I want to thank some various people. I want to thank Elizabeth L. and Tim Lawrence, Sue Kobe, and Karina Sakalakas, who have helped out in various aspects of this project. Of course, the grower cooperators. We've worked with the whole suite of grower cooperators within the state. I also want to acknowledge Layton Oversum of the Whatcom Farmers Co-op. So this project began around April of 2014, and I came to Washington State in March of 2014. So he was really essential in helping us identify grower cooperators for this project. And then I want to thank the various people that helped collect these data, Sean Watkinson, Rachel Weber, Carrie Scott, Ben, China, Matt, Rachel, and then in Eastern Washington, Doug Walsh, Tora Brooks, Yajun Lee, and Marina. And then lastly, I want to acknowledge the funding for this project, the Washington Blueberry Commission and the Northwest Agriculture Research Foundation. So thank you. And with that, can I answer any questions?
Yeah, we've got a couple minutes for questions. I'm going to start one off, though, from Prosser. We're webcasting over to Prosser today. And we have a question. Would doubling the number of hives per acre be expected to double the number of bee visits per plant?
Sure. So, I can't confidently say yes to that because, in some of the fields that we visited, the stocking rates were at 6 hives to the acre. But when we looked at the visitation rates, they weren't any greater than 3 hives or 2 hives to the acre. So, a lot of it depends on the strength of that hive. So conceivably, if you are doubling hives and they're good, strong, healthy hives, you could see an increase. But if they're not, then you wouldn't expect to see much of an increase. Mm-hmm. Yeah.
Is this an issue in British Columbia?
Yes, British Columbia also does have reduced honeybee visitation compared to these standards. And been speaking with Elizabeth Fell at one point in some of their publications that they've had, and Eric Gerbrandt. And again, a lot of this is due to variety. So the study by Chrysalis et al. That was actually done in British Columbia, and they looked at mostly the focus was on how floral morphology affects honeybee visitation, but they were still below that 4 to 8 recommendation. Mm-hmm. Yeah.
I have 2 questions. The first one was the brood pheromone. Is work continuing on that? And
yeah. Yes. So Ramesh is doing that work, and he's been looking at the brood pheromone on various crops. There was a really great publication that recently came out in carrot, and he's been looking at that in blueberry as well.
Is there a commercial product available at this time?
There is a commercial product, yes, and I can provide some of that information if you are interested.
Okay, thank you. The second question was, what's next now?
What's next? So for my program, we're really interested in natives, and we submitted a proposal to the Blueberry Commission to help support a project where we'd be looking at supplementing honeybees with native pollinators, looking at a native bombus species in particular to see, if we rely exclusively on natives, that would more than likely be cost prohibitive. But if we can supplement and provide additional native pollinators in our Western Washington blueberry plantings, do we see a benefit with that? And is that benefit, is it economically a viable option? So that's hopefully the next step.
Yes, you mentioned Eastern Washington and Western Washington. I know cranberries in the Oregon coast, they have a real trouble with pollination because there's so many alternative plants that the bees prefer over the vaccinium. I know in Western Oregon, you got to be real careful with maples and other trees that are blooming because the bees prefer the native vegetation over the vaccinium. So here in this area, I would expect that to be an issue as well.
Yes, but that's a good question. I've also worked with cranberry in the past as well and done similar projects with cranberry. And cranberry is a vaccinium crop, just like blueberry. It doesn't have the flower morphology that is really adapted for honeybee visitation. So in that situation, what the data that I've seen suggest is that honeybees are going to these alternative sources because the cranberry itself is really not a very good flower for them to pollinate. They have a hard time landing on the flowers and pollinating that particular plant. And we're seeing similar situations with blueberry, and it's more or less exacerbated by the variety and the morphology that variety has in blueberry.
Okay, I think we'll move on. I'd like to thank Dr. DeVetter for the first presentation. If you have any questions, you can talk to her at the break or the lunch. Our next speaker will be Dr. Tim Lawrence.
Lisa.